Oh, I am available to take your calls. Nope. Okay. My sound levels are off again. It's not working quite right. I hope this sound records. I'm going to double check this after I'm done. This is going to be weird when you guys listen to it. So this is my idea of a joke. Hey, let's do all of Minitab. And I mean it. I'm going to go through and show you how to do everything that you maybe forgot how to do. And I'm going to do it in order too. So I'm also going to attach this document. Well, actually, that's kind of pointless. I don't know if I need to attach this document. Let's do all of Minitab. So I have a vehicle survey that was given to some students in Minnesota that I stole from another stats book because I can't remember which one it is, so I can't cite it. So I'm literally stealing this time. I just need something that had enough variables for me to be able to do everything. So I'm going to show you how to do some tables, some charts, some histograms, like everything you know how to do. This is going to be great. I hope you're excited. I have no idea how long this is going to be. Let's find out. Okay, so first up, let's create some tables. What do I mean by that? I'm going to move this to the side so it's kind of out of my way and that I don't forget anything. I probably won't. So the first thing we're going to do is we're going to create some tables. So how you find tables are actually pretty easy. We go up to Stat, Tables, and we have only ever used tally individual variables. Good times, right? So what do we want to tally? Let's count how many types of, no, that's type only has foreign and domestic in it. That one's kind of boring. And gender is only male and female. That's kind of boring. Let's do vehicle driven so we can see all the different types there. So do you have an SUV? Do you have a station wagon? Fun fact, when I lived in Colorado, for some reason, my four-wheel drive truck counted as a station wagon, which makes no sense. And we're going to do counts. So remember back to the very beginning of Stat 1, counts in a table means that I am doing a frequency table. Good times. Let's hit OK. Ooh, so there's SUVs and stuff in there too. Wait, I can see SUV. That was dumb of me. There's cars. That's great. So here's all my different categories in this categorical variable. Turns out there's 4. That's fun. And then here's all the counts for all those. So it turns out car actually is the most popular, even though it's not the first one at the top of the table. Well, I didn't know that. Truck is the least popular. Good to know. It doesn't make sense for Minnesota. Maybe that's not where I got this data from. Either way. So that's where we're at. And since this is using counts, this is a frequency table. Yay! Let's create a relative frequency table. So we're going to go back to Stat, Tables, Tally Individual Variables. Since I've already done vehicles driven, which was the most interesting one in here, let's do whether or not someone is satisfied with their vehicle. So we'll throw that in there because I've definitely driven a car I didn't like. And since I've already done counts or a frequency table, let's do relative frequency. So I need to turn on percents and turn off counts. And let's see how this looks. Okay. Oh no. Oh yes. Oh my God, I read this wrong the first time. I thought no was 70%. So it turns out 30% of these individuals really like their car. 70% really like their car. 30% do not. So that's where we're at with that. The only downside to this is you miss the fact that there's actually 50 people in the data set. So I don't know how many are in here based on this. All right, that's the end of tables. Let's make some charts, yo. So if you remember charts C for categorical variables, you could only do charts to categoricals. And I've already used vehicle driven and satisfaction. So you can pretty much guess that I'm going to do the other 2 categoricals in here, domestic and foreign, and gender. Yeah, let's do this. So we're going to go to graph, which is where all of our visuals are at. And let's do a bar chart. Yay. So I'm going to do counts of unique values. I'm not going to cluster or stack anything for this first one. And let's throw domestic in there and foreign, so type. Yay. And hit OK, because I'm not going to mess with anything else on this one for now. Oh, it's so cute. Oh, so it turns out I have more domestic vehicles than foreign vehicles, although they're not that far apart. So that's interesting. Let's create a pie chart. So let's go to graph, pie chart. Let's throw the gender variable in there since I haven't done that one yet. This is going to be so boring because it's just going to have 2 parts to it. Oh no. Boring pie. Oh, so those were really disappointing, weren't they? Okay. Yeah. I didn't know there were more females in this sample. I thought there were more males. This has got me biased because of how many males are in the top. Sneaky. I was using my visual bias. Let's create a more interesting chart. So you might be interested on whether or not gender has an effect on what type of vehicle you are likely to buy. Like, do more men buy domestic cars than foreigns? Let's find out. And we're going to do that by clustering. No, let's not cluster. Let's stack. Wait, this is the one you can't do on Minitab Express. I'm going to do it anyway. Here we go. So we're going to throw in, was it type that's foreign domestic? Yeah, it's type. Okay. So we'll throw type in here, and then we're going to separate it out by gender. So that's going to create my stacks. And then I'm going to hit chart options. And then I want to do it accumulating across Y across X. Do I want to do it across all categories? No, let's do it within level, because that'll split it between. And I think I want to do it as a percent as well. So what I'm doing is basically making each bar represent a type, and then it's separated by gender. So I'll be able to see if there's more of one gender present in one than the other. There we go. Oh, interesting. Okay. Not what I was expecting to happen. So this is 100% of all the domestics. I'm looking at just domestic cars, and it appears that it's about even for domestic. But when I go to foreign cars, more females appear to buy foreign cars than males. That's a rather interesting graph. Fun fact. One of the reasons why you might want to stack and group in this way is because I just realized my sound is really going off. Hold on. Sorry, you're not supposed to let it redline, and it was totally redlining. So as you look at this, it takes care of the size issue. So if your sample happens to have more men or more women in it, or just more of one type of car than the other, using the percent counts instead and then splitting it up across a level for its percents prevents that size difference, and whether or not that size difference causes your visual bias into thinking one group shows up more than the other, or also known as Simpson's paradox. Woohoo! All right, so done with charts completely. Let's move on to doing some descriptive statistics and some histograms. So I think I'm going to do my histogram of miles driven per week, because I think that'll be an interesting one. Let's see how it looks. So we're going to go to graph, histogram. We're just going to do a simple one. If you want, you can do some groups. Maybe I'll group that by gender next, or maybe satisfaction, because it seems reasonable that people who are more satisfied with their vehicle might drive it more. We'll find out. That seems like an interesting one to look at. So I'm going to put in miles driven per week and see if that looks cute. Oh, that's a very skewed right distribution, isn't it? And I've got a couple values that are a little bit larger than everybody else. I bet you I should make myself a box plot of that. Woohoo! To see if I have some outliers. In fact, let's do that now. Graph, box plots. I'm just going to do a simple one and throw miles driven per week in there. See if I can get me some outliers. I do have 2 outliers. See, they were suspicious, and it turns out I was right. That's interesting. And this is showing skewed left to it as well, because if you look to the below the median, this spread looks much more narrow than above the median. So the 2 sides do not look equal inside. So remember, this longer side here doesn't mean, or sorry, this thicker box here does not mean more data. It's the same amount of data. It's just spread over a larger space or a longer space or more values, which means that it's got the same number of individuals in those boxes in the histogram, but they're spread out more on one side. And that's what you're observing here. So that's kind of fun. I actually picked a good variable the first try. Awesome. Let's see if I can screw that up by creating 2 separate histograms. Oh boy, I am not excited about this. I'm worried. So we'll do with groups this time for fun. And so I'm going to do miles driven per week. And then I'm going to separate it by satisfaction with vehicle and see if this does anything interesting. I'm scared. Uh-oh, they overlap completely. So that means I'm probably wrong. Although pink looks much, it's got the outliers in it. I don't know. This is really hard to tell. When I'm dissatisfied like this, I usually go to box plots next. Let's see what happens if I make more than one box plot with these groups and see what happens. So same thing, miles per week. Man, I'm going kind of fast. I should slow down. Satisfaction to separate. Let's throw her both up there. Does it look like the pink stuff's bigger? Uh-oh. I need my other graph back. Where did it go? That's the pie chart. All right. Window. Where's my histogram of miles per week? There we go. Let's line these two up next to each other. Let's see. Yes, I like my cars, the pink one, and that one was the one that looked like it had some higher values in it. That's interesting. So I got some up here, some outliers, and it does look like the upper range is a little bit higher and it's a little bit above, but these medians aren't that far apart. So on average, they're about the same. But this data has some outliers, which can make it seem larger. So if you did the means of these, I betcha this one, well, because it's got outliers, is going to be much higher. So it might confound you into thinking that the people that are more satisfied with their cars drive them more or drive more miles per week. But actually, when you look at the medians, they're not that far apart. I bet you that comes out not being significant at all. So that's an interesting observation to make. All right. Speaking of interesting observations in relationships, I am done with histograms. Let's look at descriptive statistics to see what's going on here. So let's see average number of children and average number of riders. Let's figure out, oh, those are averages already. Oh, I don't want to do an average of an average. That'll be weird. Let's do miles from work. Let's see how far people drive to work on average. Well, we'll find the average, not on average yet. So to do descriptive statistics, we go to Stat, Basic Statistics, Display Descriptive Statistics. So descriptive statistics are things like your mean, median, mode. We don't do mode anymore. I keep saying that one. Or some of your spreads like the range, the IQR, or the standard deviation. Maybe you want to know the min or the max. I want to do miles from work. And I'm going to hit my statistics button. So this has got some of the standards on here, but I'm going to pick my own. So I'm going to hit none on here to make it uncheck the default statistics. And I think I'm going to do the mean and the standard deviation. But I also am going to do the 5-number summary because I like the 5-number summary. So I can get a look at this. Because in particular, I want to be able to compare the median to the mean and see if it is skewed, like my graph indicates. Oh, no, wait. Yeah. No, wait, I'm doing miles from work now, not miles per week. So this is probably going to be maybe skewed, maybe not. Let's find out. And there we go. There's my mean this time. Most people live in this sample, 18 miles from work. Oh, that's kind of, like a 20-minute drive if you're not in bad traffic. Although if you're like my brother-in-law and you live in Detroit, that's probably like an hour. I don't understand why anybody does that. It would drive me insane. The median's only slightly bigger, so, I mean, this is showing some slight skew. At this point, I would do a graph just to see if it is skew, or I would compare the distance from quartile 1 to the median and quartile 3 to the median to see how big of a difference that is, and that's looking pretty skewed, because if you look on one side here, 18 to about 5, that's 13, and then 18 from 23. Oh, that's about the same. It's about 5. Okay, so these aren't too far apart. This is looking actually pretty symmetric then. And then out to the maximum is about, why am I failing at this? It's about 13, 14, 12. I can't count. Why am I failing at subtracting? And this is about the same. It's not that far. It's probably not skewed at all. It's looking very symmetric, which kind of makes sense. People don't like to live like an hour away from work. This person probably hates driving. Although I used to like driving home from work late for a long time, because it gave me like meditative thoughts of, going over my day, and I decompressed by the time I got home and had more effective time at home. Let's do some linear regression. All right, so to do linear regression, the first thing you want to investigate is, do I have a strong linear relationship that I can use to be able to do some linear regression? So I'm going to go to graph, scatter plot to see if I can get some linear relationships. We've only ever used simple. Simple is the easiest one to use, so that's all I'm going to do. So I think what I want to do is I want to predict how much someone drives per week, how many miles they drive per week. So I'm going to use that as my y variable, number of miles driven per week. And I bet you a strong variable to predict that is how many miles they drive from work, miles per week. But I'm also going to do their age, because I bet you younger people drive a little bit more than older people, and miles per week. And I don't know or remember what number of hours is, so I'm not going to use it. I think instead I'm going to use average number of riders to see if that has a relationship. So I'm just looking to see, is there any of these that look like they have a strong linear relationship that I can use for linear regression? And then I'm going to hit OK. Ooh, well, that one turned out terrible. Guess I won't be using that. This one I might be able to do. Oh man, none of these really look good. This one's okay, but it's clearly got some like non-linear shape issues. And it's looking like age is the best one I've got, and even then it's not very good. Ugh, yeah. Ugh, bad. It almost has like a peak shape, which is interesting. Like, once you hit 45, 50, you don't want to drive as much anymore. That's so what this is telling you. That's interesting. Oh, this would benefit from what we call partial linear regression, where we do one part and then another part, which is kind of cool. This one, I just don't think I'm going to be able to do it, even though it's the better looking of the two of them. I think I might be stuck with doing miles from work. Huh. None of these is really all that good. Huh. Well, let's just throw all our quantitatives into correlation and see who might be the best. And then we'll make a linear regression of those. So we'll go to stat, basic statistics, correlation, and I'm going to throw all my quantitative variables in there. Actually, I changed my mind. Stop selecting these. I'm going to throw everything in there but number of hours, simply because number of hours, I don't remember what that is. I think it's the average number of hours spent driving, but I do not remember. So I'm going to select the display p-value button because we don't use it at all. And we're going to hit OK. Let's see. Oh, that's why. None of these really look all that good, except for average number of riders seems to correlate with number of children you have. That's not shocking. If you have kids, you're more likely to have them in your car. That's all this is saying. Crap. Oh no, this data set is not good. All right, the best I've got here, other than number of children and average number of riders, is average number of average number of riders and miles from work. Oh, that's interesting. So if you have people that you drive around a lot, you're less likely to drive as far for work. Oh, I bet you that's a confounder with number of children. You're not going to live as far away if you have kids. Interesting. Interesting. Okay. I don't like that either. Okay, if you have kids, you're more likely to drive if you have more kids. That's also weird. Huh. This one's hard. Screw it. Let's just do the strongest one. So, rather than using average number of hours you drive to predict the number of children you have, I'm going to go the other way. I'm going to see how much having a kid affects how much you drive, because that seems like an interesting relationship. So let's go to stat, regression, fitted line plot. In case you didn't follow that discussion I just did, I said I want to use whether or not you have another child, number of children, predicts or changes the average number of hours you drive. So the thing I'm going to be predicting is my response variable, and that's my average number of hours you drive. Average number of riders. And then number of children. So number of children is going to affect your number of riders, definitely. Let me do some graphs here. Let's do a residual versus fit so we can see just how bad the residuals look for this, because I don't think it's going to be good. Even though this is a stronger correlation, I still don't think this is going to look very linear. Okay. Ooh, it's actually better looking than I thought it was going to be. Maybe I should have did this first. I probably shouldn't have done this in the first place because these are all counts. Oh, that looks pretty good. Oh, and R-square is pretty good. Yeah. So this tells me that the number of children you have is able to account for about 67.1% of the variation in the number of riders you have when you drive around in your car, which is interesting. This also says that when you look at your average number of riders in your car, if you have 0 children, the intercept is 1.032. So if you have no kids, you're likely to have only one other person in the car with you half the time. So maybe this says that everybody has at least a friend, or they're married when they're riding around in their car. However, if you have a child, for every child more you have, the number of riders in your car increases by 0.74, which is funny, because that means your kid is only with you like 74% of the time. Oh, that's hilarious. That's a very weird linear regression. It's not even that good. I kind of like it. Okay, Minitab. That was fun. I'm doing the weirdest things with Minitab today. All right. Let's do a geometric. So the thing is, chapter 6 and 7 show up a lot in the other video that I'm recording today, so I don't think I'm going to do a geometric, binomial, and a normal. I think I'm going to skip ahead to chapter 9, 10, and 11, because quite frankly, chapter 6 and 7 were covered a lot in the other video that's about 20 minutes long. So for this one, I am going to, at already 20 minutes, jump over to doing a confidence interval for a proportion, a hypothesis test, and then a confidence interval for a mean and a hypothesis test for a mean. So the first thing I'm going to do is I'm going to do a confidence interval for a proportion. So I'm going to pick one of these that has yeses and nos or ones and twos or just two options. So domestic and foreign is the one I'm going to use first. So I'm going to see what proportion of my population that this was taken from likes domestic or foreign cars. So to see that, I'm going to go to Stat, Basic Statistics, one proportion. I'm hoping you notice that the type of variable I chose was one of these T's, which stand for text, also known as categorical variables. Yeah, one or more samples in each column. Since I have the data here, I don't need to use summarized data. Summarized data is what you would use if it was just described to you, like 30 out of 100 have domestic cars. So I'm going to go ahead and click type and throw it in there. No, and since I'm doing a confidence interval, I don't care about the hypothesis test proportion of this box. I'm going to hit my options. The first thing I need to do is I need to change this into the normal approximation mode because that is the only mode you use. And this needs to be a not equal to an alternative hypothesis. For fun, let's do a 90%er rather than a 95 for fun. And then let's hit OK. And then OK. So this tells me that when I look at the population that this sample was taken from, I am 90% confident that that population, in that population between 28.6 and 51.4% of individuals own a foreign car. Notice the event type up here. If you use Minitab Express, you can pick your event type. I can't do that on Minitab 18. Shady, shady. Cool. So now that I've done a confidence interval, let's perform a hypothesis test. So a natural choice for hypothesis test would be to see, do I have equal representation of the genders in my sample? So I want to see, do I have an equal number of males and females? So I'm going to go up to Stat, Basic Statistics, and I'm still doing proportion stuff because I'm still looking at categorical data. I'm going to throw gender in there, and I want to see, am I half or 0.5? Let's hit our options button. I have a sneaking suspicion that there are more males in this sample, and I'm going to let myself be biased by the fact that when I look at the first 16, it's mostly male. So I'm going to change this to being a greater than. Woohoo! As a polite reminder, when I am doing a hypothesis test, I do not care about the confidence level. Doesn't affect it at all, so I can just leave that as is. Let's hit OK, and hit OK again. And, oh, there's my hypothesis test. Ooh, it's looking like... Let's see, there's my hypotheses. Oh, well, I was wrong. Alrighty. So, with a resounding no, I just look at the first ones I can see, is very, very incorrect. It appears that my evidence seems to support that it looks like that there is an equal proportion of males and females in my population, rather than it being more men than women. Fun fact. So... I was wrong. Very wrong. That was kind of fun. All right, let's move on to looking at means. So since I'm going to be doing stuff to quantitative data, I need to focus on the end of the worksheet, which is all quantitative information. Remember, number of children, just counting something isn't technically quantitative, so I'm going to steer away from this. Average number of riders, same thing. So I'm going to stick to looking at age and number of miles driven per week. But I think actually I want to do number of miles from work because I did that one earlier. I want to see what the prediction is about how far people drive from work typically. So I'm going to do a confidence interval on this one. So we're going to go back to Stat, Basic Statistics, and to do confidence intervals for a mean, we use the one sample t-test. So my data is in a column, so I'm going to click into the white box below, throw in miles from work, and I'm doing a confidence interval, so I don't want to do the hypothesis test. I'm going to hit my options, and let's see, not equal to, and let's do a 98 for fun. 95 is what everybody does, so, you know, we'll try something different. Okay. Okay. Where are we at? Ooh, all right. So remember, this describes the population. So on average, It appears that people drive in this population between 13.5 and 22.5 miles to work on average. I drive like 6, so this I'm like really low compared to everybody else. Ooh. As you look at this, please keep in mind that this is the mean of the sample, so that's the mean of this column. Here's the standard deviation, that's the standard deviation of this column. And then right here's the SE mean, aka the standard error of the mean, that's the spread of the sampling distribution for this sample. Fun fact, in case you needed that. Okay, so now that I've got this, let's see, I'm going to do something kind of weird. So most people work 5 days a week, right? Roughly. And the average appears to be somewhere between 13 and 22 for this. So I'm going to say the average miles driven per week is like, I don't know, 60 miles based on this little bit of information here. So I'm going to use that as my prediction for what my mean's going to be for miles driven per week for C7. So I'm going to do stat basic statistics 1 sample T. And this time I'm going to do a hypothesis test because I'm assuming people drive the most from having to go to work. So I'm going to do miles driven per week, throw that in there, do a hypothesis test. I've already forgotten what value I picked. I'm going to do 60. That seems reasonable because, you know, you drive like 5 days a week. It's got to be a little bit bigger than 10, which would be 50 because, like, you know. Actually, let's do a little higher. Let's do 70 because you probably go grocery shopping and do other stuff too for leisure nearby where you live. Yeah, I have no idea what this is going to be. Let's hit options. I have a feeling this is going to be real wrong. Because it's only counting for, oh no, this has got to be so wrong because that's only going one way. Let's do like 200 because it would be 140 and then I'm adding more miles for doing other stuff. So, again, I'm just going to look at the alternative. We'll use a not equal to since it might be bigger, might be smaller. Let's hit OK. I have no idea how this is going to turn out. Let's hit OK. I'm okay with it. Oh no, I'm so wrong with my prediction of 200. Okay, so I said suppose the mean's 200. The alternative is it's not. It looks like it's super not, right? It appears to be that the average driver does not drive 200 miles per week. If you wanted a better estimate for this, you would use a confidence interval. Notice this comes with a confidence interval. This will only happen for a not equal to. It's actually somewhere between 400 and 600. So I was like really under. That seems really high. I wonder if these are college students. I think these were. Oh crap, look at the ages. Oh no, they're not. These people have kids. What am I talking about? They're going to soccer practice and doing all kinds of stuff. What is this person doing? Okay, I'm distracted. He's driving a lot. Maybe he's a trucker. I don't know. Okay, so that's all of Minitab. Whoa. Minus probability. So I bookended it. I did the beginning of the class and the end of class. Fun times. This video is too long now, so I'm going to go away.